Hi there. Here we're looking at a standard intercept form and vertex form coordinates. So this is about being able to look at a graph and know about what the equation should look like. Here, the things that I'm looking for to compare to these, I see some of these have a -2 for A and some of them have a 2 for A. If A is positive, the parabola opens upwards. If it's negative, the parabola opens downwards. I see this is an upward opening parabola, so that eliminates the last choice and the first choice. And so I'm down to this one and that one. I notice that they're the same except for this number on the end. This one is +3, this one is +1. And that number, C, will correspond to the y-intercept. So the correct answer is this one here. This is the equation that matches this parabola. All right, now let's review our standard form coefficients, or what those numbers mean. A standard form parabola is always of the form some number multiplied by x squared, and I'm going to copy out the one that I believe is true, 2x squared minus 4x plus 3. Okay, so ax squared plus bx plus c. And this is going to have to do with the traits of the graph. All right, a gives us direction of opening, in this case upwards. So it's A is positive and indeed a little bit stretched. So the A of 2 fits. The C value here tells me the location of the y-intercept. And I can see over here that it's 3. It's 3 right there. And so that being 3 makes sense. And then this number here, they probably won't talk to you about, but it means it's because it's negative, it's going down as it crosses the y-axis. Notice that this parabola is descending in this area and then starts ascending over here. But like it has a slope of -4. We'll submit this one, say yes. Hooray, that's good. Let's do another. These should be fast for you. You want to be fast with these. Here I notice that it's a parabola opening upwards, so that's either the first or the last one. Its y-intercept is at -2, definitely not -6.5. -6.5 might correspond to the vertex, but who cares? This is standard form. It shows me y-intercept of -2, so that one is correct. All right, now let's take a look at factored form. So intercept form, they call it intercept form. Why? I don't know. I would call it factored form. All right, so here, again, A tells me the same thing. It's opening upwards. But then I can get the locations of the roots from these numbers. And I see these ones are correct because the roots are at -4 and -3. And these are sign flippers. So that one is correct. Let's review factored form. Factored form looks like y is equal to a multiplied by x minus the first root multiplied by x minus the next root. These minuses mean you need to flip the signs of r and s to find the roots at r0 and s0. The roots being the places where the parabola touches the x-axis. Okay, and those are the things that this form gives us. The A gives us the same information. In this case, the parabola is opening upwards. If A were negative, it might look like that, where the parabola would open downwards, but you would still get the roots there and there. Okay, so in this case, this one is the correct answer. Let's submit it and do another example. These again, want to be fast for you. New problem here. Okay, so I noticed that this one is also opening upwards. It has roots at -7 and -2. So these haven't flipped the signs. We definitely want ones that have signs flipped, that are positive, because these are negative roots. Remember to flip the signs. And with a positive A value, not a negative A value. Submit that answer. Yes, good. So that's how you work with intercept form or factored form. Now let's take a look at vertex form, which we looked at in Unit 1, and we're looking at again because it's really handy dandy. Reviewing vertex form now. Vertex form will always look like this. Y is equal to, still the stretch factor there, always the same number, multiplied by x minus h. H is a sign flipper, and that bracket will be squared, plus k. K is not a sign flipper. So in this case, the vertex is at h, k, and remember to flip the sign for h. So if we had a parabola like that, with this being the point hk, it would have h is some number, k is some number. It would have this form, its equation in vertex form. All right, so let's take a look. This one's vertex is at -3, -1. So, and it opens downwards. So I know I'm looking for a negative a value, and they all have the same a value, so that's convenient. I like this one, except, oh, that's a +1. I want this one here with a -1, okay? This one's a sign flipper. I'm looking for -3, so that should be +3, because it's a sign flipper inside with the x. This one, not a sign flipper. It's down there at -1. Submit that answer. Yes. Let's do one more example, and then bid adieu. Okay, new problem. Whoa, where is it? There it is. Okay, the vertex here at -6, -3. So I'm looking for x plus 6 minus 3. All of these have the same a value. This is definitely a negative a value, so it's this one here. Let's do one more example, see if we can get a vertex that's not down in that quadrant. There we go. So this one has a positive x value there, so I'm looking for x minus 2 and x minus 2 and then -4 there. It's this one. It's not that one because this one has a negative a value. That would open downwards. That would be like this. But this one opens upwards, so it's that one. Hooray. So do these quick and practice your different forms. Any questions? Hit me up by email. Bye.